For our second look at the binomial theorem, we're actually going to be dealing with the exact same questions I did in the last video, but now I'm going to show you another way to generate the coefficients instead of using the Pascal's triangle pattern. So the first thing I need to do is define a couple new terms for you guys, some new math operations. The first one being a factorial. Well, a factorial is the product of an integer and all of the positive integers that are less than that number. The notation for when to take a factorial is an exclamation mark following the number. So here's a quick example. I have a number followed by an exclamation mark. That's how I know it's a factorial. And the positive integers that are less than 5, well, that would be 5, 4, 3, 2, and 1. So if you multiply these numbers together, 5 times 4 is 20, times 3 is 60, times 2 is 120, and then multiplying by 1 doesn't change anything. So that's how you would compute a factorial. 5 factorial is equal to 120. Now, one important note, a lot of people, whenever they see a 0 factorial, they try to say that it should equal 0. But I'm just telling you that as a rule, 0 factorial is equal to 1. This is just by definition. We say 0 factorial equals 1 because we have some formulas coming up where you will sometimes be subtracting two numbers and then taking the factorial. So it is possible to get a 0 factorial in them. And if you let it equal 0, then those fractions would come out undefined. We wouldn't be able to find an answer for them. So 0 factorial is equal to 1. It's just by the definition of what a factorial represents. Now, I have a note down here that if you got the calculator I recommended in the syllabus, this is the one I usually have on hand to loan out to students during class, the TI-30XS Multiview. You can actually enter factorials like this one in the calculator by pressing, in this case, the 5 key. So press the number, and then hit the PRB key, which is in the top left. It's very close to the second green key, and then hit 3. Select the third option within that menu, which is factorial. And once you press enter, it will compute the answer for you. So here's another definition, and this is why I had to explain what a factorial is in case you hadn't seen it before. We're actually concerned with something called a combination. Well, combinations are usually used to make a selection of objects out of a set. For example, maybe you're reaching into a bag and pulling out some dice, for example. And combinations are used when the order does not matter. So which object you picked first and which object you picked second, the order does not matter. So the most common notation for it is n, a little subscript n, and then a capital C, and then a subscript r. And n is going to be how many objects there are. For example, if you have a big bag of various tennis balls, for example. So say there are 10 tennis balls in there, then n would be 10. And then if you are picking some different tennis balls out of the bag, maybe you have some that are different colors or something, r is how many you're going to draw out of the bag. So you would have something like 10C2. And the way we read this is the number choose the other number. So the way this is read, you would say 10 choose 2. And this is another way to write the notation. We will be using this one a lot for our current section. It's the same thing. You would say n choose r. So how many objects you have total and how many objects you're drawing out of that collection. So n choose r can also be written as n choose r. What's important is that this is the computation you'll be performing. So the number on top, however many objects are in the bag, you would take that number factorial, and then you would divide by the bottom number factorial, and then that number gets multiplied by the difference between these two. So if it was 10 and 2, for example, you would do 10 minus 2 is 8, so 8 factorial. And I have a quick example to show you this computation right here, and I'm going to show you some shortcuts on it that'll help you with doing these without a calculator. So this is the example of saying we have 7 objects in a bag, and we're going to pick 3 of them. So 7 choose 3 is the way I would pronounce it. That means 7 factorial on top over 3 factorial on the bottom, and then the difference between the two numbers, 7 minus 3. You could have just written 4 factorial here, but I wanted you to see where the numbers were coming from. And then you would list out that 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Well, here's one of the shortcuts. Usually when you have factorials divided by other factorials, what's nice is that a lot of the numbers will cancel out. So in this case, the 1s, the 2s, the 3s, and the 4s. So there's honestly not as much to multiply out as you might think. Now, in this particular case, I even have a little bit more I could cancel because I know that 3 times 2 times 1 is 6. So I could actually cancel out the 3 times 2 and the 6 on top, which means the only stuff that's left is 7 times 5 equals 35 divided by 1. So factorials do get very big very quickly, but when we're dealing with our computation here, many of the numbers will be canceling out. Now, combinations can also be calculated in the calculator, the TI-30XS multi-view. To enter those, you do the number on top, then you press that PRB key, and then you select the second option in that menu, or you can just press 2, and then you select the bottom number. So you could do that on this one, for example. If you have the calculator on hand, hit 7, PRB 2, and then press 3, the bottom number, and enter. And it should give you the answer of 35. So here's why I'm teaching you about factorials and combinations. You can actually use combinations instead of Pascal's triangle to get those coefficients for the binomial expansion. Now, the other numbers still follow the same pattern. Whatever you have in the a spot is going to start from the n power. So a to the n power, and then subtract 1 from the power, subtract 1 from the power, subtract 1 from the power, and keep going. So if you started with the 6th power, you would have 6, 5, 4, 3, 2, 1, until you get down to the 0 power. The b value still counts up. So you still start with b to the 0 power, and then b to the 1st, b to the 2nd, b to the 3rd, 4th, 5th, etc., all the way up until you hit the last number, whatever exponent was on the outside, so b to the 6th. What's changing is now I'm showing you another way to get that third part of the pattern. You can actually do combinations where you start with whatever the exponent is, and then you would hit n choose 0, and then for the next term, n choose 1, and the next term, n choose 2. And remember, for a specific example, you'll have a number out here like the 6th power that I was using for the example. So it would be 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, all the way up until you hit 6 choose 6. When you have the same number on top and bottom, that would be the coefficient for your last term. So this is another way to create those Pascal's triangle terms, which can be nice, especially for the higher exponents, where you don't want to have to go through and create the 15th row of Pascal's triangle. This way you can just jump straight into the 15th row by doing 15 choose 0, 15 choose 1, 15 choose 2, etc. So this is the exact same example I worked out in the previous video, but now I'm going to do it using the combination approach instead of Pascal's triangle. So remember, there are going to be 3 parts to our pattern. First, we're going to look at the combination part. That's the new part that we're interested in here. So my exponent is a 4, which means I'm going to start with a 4 choose 0. So the number on top stays the same all the way through. And then the numbers on the bottom just count up. So 4 choose 0, and then 4 choose 1, and then 4 choose 2, and then 4 choose 3, and 4 choose 4. Once you have the same number on top and bottom, then you are done listing out your terms. So that's the pattern. We'll have to remember how to compute this in a second. And then the next part is you take the a term, which in this case is x, the first part of your binomial, and this one's going to count down. So it's going to be x to the 4th, and then the next term gets x to the 3rd, and the next term gets x to the 2nd. Next term gets x to the 1st, so I'm just going to write x, that is x to the 1st, and then I'm not going to write x to the 0 power because that's unnecessary. And then for the other part, the b term, this one counts up for the exponent. So it's going to start with 2 to the 0, but I'm not going to write that down because it doesn't change anything. And then 2 to the 1st, and 2 to the 2nd, 2 to the 3rd, and 2 to the 4th. One thing you might notice is that the pattern for the number on the bottom of your combination and the b exponent, so it started with exponent 0, then exponent 1, exponent 2, you'll notice that those two numbers will always match because they follow the same pattern. They start from 0 and they count up, and they both do that. So that's a nice way to make sure that nothing got unaligned or a number was skipped. So these terms are being added. Now I would just go through and need to compute each of these. So you could use the formula to compute 4 choose 0, and then to do that you would just be looking back at what the 4 choose 0 means. So you would have 4 factorial divided by 0 factorial, which we said is 1, times 4 minus 0 factorial. So if we compute that one, we would have 4 factorial over 0 factorial times 4 minus 0, which is still just 4 factorial. Well, I told you 0 factorial is equal to 1, so we can actually just kind of ignore that part because multiplying by 1 doesn't change anything. And this would be 4 times 3 times 2 times 1, over 4 times 3 times 2 times 1. So everything would cancel out on top and bottom, the 4, 3, 2, and 1. So all that's left here is a coefficient of 1. So it's just 1x to the fourth. And you can check that with Pascal's triangle if you want. And then you would go on to the next one. The next one would be 4 factorial over 1 factorial. And then 4 minus 1 is 3. So 3 factorial. Now 1 factorial is still just equal to 1. So all that would be changing on this one is you would have 4 times 3 times 2 times 1 and 3 times 2 times 1. Well, that means the 3's, 2's, and 1's would cancel. So all that would be left is the 4 on top. So this coefficient is 4, but then I do still have to multiply by that 2 there. So we're actually going to have 4 times 2 times x cubed. Don't forget about the b value. So 4 times 2, this one's actually going to be a coefficient of 8x cubed. And then for these other ones, I'm just going to start doing this with the calculator now. So the next one, we have 4 choose 2. So you would hit 4, PRB 2, and then 2. Top number, choose bottom number. And the calculator gives you that this answer is 6, but I need to multiply that by the 2 squared that I have. So it's 6x squared times 4. And the 6 times 4 is equal to 24x squared in this case. So that would be my next term, 24x squared. And then on to the next term, we have 4 choose 3. And I'm going to take that number and multiply it by 2 to the third power, which is 8. So since this came out to equal 4, 4 times 8 is 32. And that's x to the first power. And then for the last one, we have 4 choose 4. And a number choose itself, that's always going to equal 1 as well, just as a nice shortcut. So all we really need to do is evaluate 2 to the fourth power. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So now we've created that binomial expansion using combinations instead. And like I said, you can do this with or without a calculator. So the combination approach for expanding binomials is even better when you're just trying to find one specific term. It's much better for just skipping around and not having to list out all the values in Pascal's triangle. So this time we're dealing with a 6th power expansion, and we're interested in the x to the fourth term. So we're going to look at where those numbers would come from for our combination setup. So if our power on the exponent is a 6, I know that would go 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, 6 choose 4, all the way up through 6 choose 6. Now specifically, the number I would want would be the one that is x to the fourth power. So if we're looking for x to the fourth power, remember that it starts with x to the 6th power, and it's going to count down. So we would have x to the 6th, x to the 5th, and then x to the 4th. So that's what would create the x to the 4th power term. That means that I should have 6 choose 2, because it ends up being the third term of my setup. If I'm starting with n is 6, 6 choose 0, then 6 choose 1, then 6 choose 2. And the other comment I gave you guys was that the bottom number in the combination is always the same as the exponent for the b term. So if you look back at what our b term was for this one, we have -2 for b, and it'll be to the 2nd power. That number should match the number in the bottom of the combination, b's power in the bottom number of the combination. Also, you can note that the 2 exponents for a and b, they should add up to the number on top for the combination. So since this one was a 4, I knew this one had to be a 2 as well, looking at it that way. So now all I have to do is evaluate this one piece. I don't have to go through and get a bunch of other terms. So for the combination, I have 6 choose 2, so that's 6 factorial over 2 factorial, and then the difference, so 6 minus 2 is 4 factorial, and then that's going to be multiplied by x to the 4th, and -2 squared is a 4. So I'm going to do this one paper and pencil since it's just the one computation to do. So remember 6 factorial, that would mean 6 times 5 times 4 times 3 times 2 times 1. And in the bottom, 2 factorial would be 2 times 1. And then the 4 factorial would be 4 times 3 times 2 times 1. So usually you probably wouldn't even write these parts out. You would just recognize that a lot of it's about to cancel. But I wanted you to see what was happening here. So the 1's cancel, the 2's cancel, the 3's cancel, and the 4's cancel. So all that's left is 6 times 5, which is 30, and then divided by 2. So the 30 divided by 2 is going to equal 15. And then don't forget, we still have these other parts. We have the times 4, and we have the x to the 4th power. So if I multiply the 15 and the 4, my final answer would be 60 x to the 4th. And that's it. We found the x to the 4th term. The coefficient was 60. And that's all for the notes on this one, just an alternate method instead of using Pascal's triangle.